Hello, my name is Xander and welcome back to FastAPI. In this tutorial, we look at implementing Celery, Flower, and FastAPI in Docker containers. So by the end of this tutorial, you would have integrated Celery into an existing FastAPI app. So we're just going to take a previous implementation, previous tutorial, FastAPI tutorial. We're going to take that code and just implement Celery. So we'll run Celery, Redis, FastAPI within Docker containers. So we'll go through building that up in this tutorial, and then we'll go ahead and implement Flower to monitor Celery jobs and workers. So I am making the assumption here that you understand what Celery might be used for. Here is a visual kind of representation of what we're going to be developing. And for those who don't have a general understanding what Celery is for, then I'll just quickly give you an overview. By all means, skip ahead if you're already familiar with Celery and you just want to go through the process of implementing. So let's imagine you have an API service that is quite data heavy, has quite data heavy tasks that might take a few seconds or even a few minutes to complete. The user on the front end makes a request that was sent to the server. Now, maybe traditionally the server would then perform that action. That might take a couple of seconds, might take a few minutes. And of course, while it's doing that, it's taking up the resource of the web server. And if you imagine, if you scale that up to 1,000, hundreds of thousands, that's a lot of resource from one server that has to deal with all those requests. And of course, the more requests that the web server is dealing with, potentially the slower that service becomes when others want to utilize that service. So the whole point here with Celery is it allows us to kind of offload some of this work from the web server, in this case, in this scenario, over to what might be known as Celery workers. So this might be a separate server or servers that we can deploy in order to perform these intensive tasks, processing tasks that might need to be completed. And also when we're doing that, this will work asynchronously. So that does mean that users can make a request to the web server and that the request then isn't blocked until the task is complete. The user can then continue potentially and perform other tasks whilst it waits for the job to complete. So to summarize this workflow here, the user is going to make a request. That's going to be picked up by the web server. This is all going to be on one container here. And then that's going to be passed, that job, if you like, is going to be passed across to our message broker here. And then our Celery worker, which is going to be in another container. So Redis, we're going to put in a separate container. And then Celery, we're going to place in a separate container. The Celery worker, is going to pick up the message or the job from the Redis message broker. It's going to perform the action, perform the task, and then it's going to be logged. So then we're going to implement Flower within this container, the web server container here in this case, and that's going to basically monitor Celery jobs and workers. So what we're going to end up here in this tutorial, we're going to end up with 3 containers, one for the web server, FastAPI, and Flower, one container for a Redis message broker, and we'll then also build a container for the Celery worker. So use the link in the video description, download the code. I'm just going to use the code from the previous tutorial where we implemented FastAPI with user token authentication. So I'll just go ahead and download that and I'll open that up in Visual Studio Code. So once you've downloaded the base code, go ahead and run a virtual environment. So we're just going to hook into that environment, start that up. Okay, so what we have here then, if we look in the Docker Compose file, this is code from the previous tutorial. If you haven't seen that, then maybe go ahead and do that. If you're not familiar with FastAPI in general, there is around about 3 or 4 videos kind of leading up to this tutorial, which you can also look through to familiarize yourself with FastAPI. So here you can see that we're going to be utilizing Docker Compose. So you are going to need Docker installed, Docker Desktop we're going to be utilizing here. So please go ahead and do that if you want to follow the tutorial. We're going to add to this Docker Compose file. We're going to need to add Redis and we're going to need to make our Celery worker. So those are 2 things we're definitely going to need to do here. So we're just going to make a change here in line 1. We're just going to use a slim version of Linux, if you like. So in the previous tutorials, we've been using just the default image, which was fairly large, around about a gig. So this is going to just slim things down a little bit here. So there's nothing else we need to change there. So I'm just going to save that. So looking back here in our diagram, we're going to need a container for Redis. So we're going to put Redis in a container and then our Celery worker. So let's just go ahead first and build our Celery container. Sorry, our Redis container. Okay, so in Docker Compose, let's go back to a Docker Compose. Let's go ahead and add a new service. It's down here. So we want to add a Redis service. So let's just call this Redis. And then I'm going to give this a container name of Celery work. Yeah, we'll call this Redis, sorry. I don't know why I keep saying Celery. And then we're going to need an image. So if you head over to the Docker hub, you'll see the Redis image. So here we're going to be utilizing Redis. I think the latest version is 6.2 Alpine. Okay, so that's pretty much it for setting up Redis in this scenario, at least. So now when we build our containers, we're fine, we have Redis. So because we swapped over to a slim version here, to a slim build here, it does mean we will have compatibility issues with the database that we're using, the Postgres database. So what we need to do is go into our requirements here. We won't be able to run our normal adapter, Postgres adapter. We're going to need to swap this over. So simply put here, because we're using a slim version of Linux, for example, it doesn't have all the tools that we need to run our normal Postgres adapter here. So what we're going to need to do is just remove that from our list. And then we're just going to swap that over for the binary version. And there we go. So as of recording, 2.9.1 is the latest version. Okay, so if you are seeing this error message here when you go ahead and build, that'll be why. So we can go ahead and build. So Docker Compose build. So that might take a few seconds because we need to download the image and get it prepared, etc. So you don't have to use the build command here. We could just use Docker Compose up, for example, and get everything ready. So I've just done that just to ensure that the changes I've made here in my Docker file, it will build okay. So once that's done, I can, if I go back to, for example, here, the image, you can see I've made the app image. So again, if you're not too familiar what's going on here, then maybe go back to the previous tutorials to give you a better idea of how we've kind of built up to this stage. But we built our image, and this is essentially our API image with FastAPI and our web server. So now we can go ahead now and add all the other services that we have ready to go. So that would be now everything here in the Docker Compose. So we're going to build our Postgres image. We're going to have our PG admin image to manage the database. We've got the app, and then the Redis server or the Redis container will also be made. So let's go for up. So that's going to then pull down all the images for all these different services here and get them all ready. That'll take a few seconds. So I'll just pause here. So while it's downloading that, you can see here that from the previous tutorial, this was around about a gig, the size of this image that we have for app. And you can see now we're using the slim build. You can see that that's been reduced to over half the size. So you may have already noticed this, that I made a mistake spelling Alpine. Apologies. So if you've followed that and you've made the same mistake, just need to go into the terminal again, do the Docker Compose up, and that will then finish off the build here. So what you have at the end of the day here, once you've done Docker Compose up, is we're going to have 4 images. These are the services that are going to be turned into containers. So Redis, this is going to be our PG admin, our admin for our database, Postgres database, and then we've got our app here as well, which is our FastAPI implementation, our API. So because we've used Docker Compose up, the containers should now be all running. So you can see that our Redis service is now running, as well as the other containers. So let's go ahead now and start to implement Celery. So I will start by just pressing Control-C to close all the containers. Now that will just exit all the containers here. I'm also just going to remove this image here because we're going to need to make some changes. So I'm going to remove the app image. These can all stay the same. That's not a problem. There's nothing else we need to configure there. So once we're back into the app here, we're just going to pip install Celery. That seems like a good idea, being that we're going to be utilizing Celery. So let that load up. So once that's installed, go ahead and install Redis. So pip install Redis. Here I'm using Redis 3.5.3. So you will find all this in the requirements text of the repository for this tutorial if you're not too sure what versions we're using. Now, when we're using Celery and Redis here and working with these tools, it's important because things can change and break depending on what version you're using. So if you're not too sure, head over to the requirements text and install the specific version we're using in this tutorial. So that might not be a problem if you're watching this tutorial a couple of weeks or months after this was made. But if you're looking at this tutorial maybe a year after this tutorial was made, then yeah, just take note of the versions that we're using. So just before we configure or start to make configurations, just a change here I've made to the diagram, workflow diagram here. We're going to be utilizing Redis here to essentially save the results of a task that we're going to complete. So whereas we had before, I had here in this container the results or storing results here, we're going to restore results in this tutorial utilizing Redis. So next up, I'm going to set some environment variables here for our Redis service. So let's go ahead and do exactly that. So we're going to define here our Celery broker URL. So that's going to be Redis. So that's the name of the service that we've set up here in Docker Compose. That's going to be running on port 6379. So here we're just defining the Celery broker URL, which is obviously Redis in this case. So that will point Celery over to the broker service. And we're also going to be using it as a result backend, if you remember. So let's set up that environment variable. So this is going to be Celery result backend, Redis, same thing again. Right, so that's the two variables we're going to set for our broker and identifying our result backend. So let's go ahead and build a new file. I'm just going to call this Celery. Let's just call it Celery. Okay, right, so in here I'm going to import OS and then import time. So I'm going to use these tools, and then from Celery, let's import Celery. Yep. And like we did before, if you've seen the other tutorials, we've been utilizing .env package in order to kind of load up our environment variables. So that would just allow us to access our environment variables when we're working here in development mode. Right, so so from .env we import load. So this is basically going to allow us to load the environment variables and then for us to access them, because we've set up to, haven't we? We just previously set up to environment variables. So now we can go ahead and load them. So that was a .env file. Now this is in the same directory location. So it's just dot and then the file env. So that will load up those, and then we can go ahead and use them shortly. So let's go ahead now and set up Celery. So we want to define our broker URL. So let's just configure that. So you can see here I'm using OS environ get. So that will allow me to access the environment variables which have been loaded, and I want to get the Celery broker. Okay, and I can do the same thing again for the backend. Right, so that essentially is now set up Celery. So I can now go ahead and just add a task. So in this tutorial, I'm just going to create a very simple task, which is essentially going to kind of add some numbers together and return. We're going to use time to create a to kind of showcase the fact that it might take a couple of seconds. So we're going to utilize it to simulate the task taking a number of seconds, for example. So let's go ahead and use the Celery declarator celery dot task. So name equals, and then we'll just call that create task. And then we'll create a new function called create task. And we'll take in some parameters, A, B, and C, for example. And then what we'll do is we'll just create a simple delay. So we'll define the delay that we want to create. So this is just going to, this is going to delay the task as if the task was going to take a couple of seconds, etc. So we're just simulating that. And then we can return B plus C. So I do apologize. I'm kind of assuming that you've got a general idea of Celery. So here's a task, Celery task. We're going to input A, B, and C. So A being the time we want it to be delayed, the task, as if we were creating an asynchronous task that would take a few seconds. And then we're just going to input B and C to return a result of a simple calculation. So that's a task that we're going to build. So ideally, or essentially what's going to happen now is this task is going to be sent across to our broker, Redis. Then our Celery worker is going to pick up that task, it's going to perform that task, and then return the results back to our Redis server. And then we're going to pick up those results using the Flower software package to see what's happened and the result that's returned. So let's go back into our Docker Compose file. Here we're going to create a new service called Celery Worker, and we're going to give it a container name, and then we're going to build. So here, essentially what we're doing is we're just going to use this implementation here, which is going to have a Celery installed, etc., to kind of utilize these files as our Celery worker. So we're going to run this command here to kind of start our worker. And then just make sure something with Celery, if you're looking at different tutorials, once you move up to Celery, I think 0.5 or version 5, sorry, you'll find that there was a few changes or big changes that were made. So if you are using different tutorials to help you understand and to learn Celery, just be careful of the commands utilized, and just make sure you know what version you're working with and corresponding those commands to the version of Celery that you're working with. Okay, so here we got our volume here. So that's our volume. We're just going to utilize the code here to implement this. And we got the environment here. So we're going to define the Celery broker and the result backend. So that's going to be taken from the environment variables. And then this is just going to depend on the app and Redis. So we don't really want to run this until we know that the app is working and Redis is also started. Okay, so now we have a Celery task here on our web server. We have Redis prepared, our container. We now have a Celery worker container. We haven't started that up yet, but that is now prepared. So let's go ahead now and implement Flower so that we can see and visualize our tasks, or should I say monitor our tasks. Right, so let's go ahead now and pip install Flower. So once we've installed, let's go back over to our Docker Compose file. Let's create a new service. So Flower, container name is going to be called Flower, and we're going to build command Celery .Celery Flower port 555. So that's going to start everything up, and then we go ahead and sort out our port so we can access this service. This is a web service, so we're going to access that on port 5556 mapped across to the container 5555. And then we're going to set up our environment, broker, and result. And it's going to depend on the app, Redis, and Celery worker. So here, if you're not familiar with depends on, essentially here we're just going to create a container start order, if you like. So obviously this depends on these other applications working, otherwise there's no point starting this service. Okay, so now we've done that. Let's go ahead and just double check everything. So we've got Flower installed or prepared. I did notice here I've set the command to Celery worker, And this is essentially pointing here to our Celery file. So I just need to rename that to Celery worker. Essentially, our Celery worker is going to run this task. Now, you've seen here in the implementation in our Docker Compose file, our Celery worker is basically just copying everything from this directory here. And essentially, the worker is going to perform the action here in our what is now called Celery worker _ worker. It's going to run this task. So we're just using these files here as well as the requirements to kind of build that container. Celery installed. It's got the worker task that we need to perform. So we're going to pass tasks over to, we're going to pass the parameters obviously over to this worker, and it's going to perform this task. So the attributes we're going to pass over, and it's going to perform that task. Right, so let's just make sure that's all matched up. So we've got Celery worker here, the command, and we're going to start our worker and with flower. So that is just matched up here now with Celery worker. Right. So if you now just make sure here, what I've done here, I've got Postgres, Redis, pgadmin here. You can see I don't have any of the other images. There's no containers there. So that's all ready to go. So now I'm just going to go ahead and compose up. So that might take a couple of seconds just to rebuild our worker and our app. So you can see what's happening here in the commands. It all looks good. You can see that Celery is now running. It's picked up the task, which was called create task. So that's our task name in our Celery worker file here called create task. So you can see that Celery it knows about our task. It's ready to potentially perform that task. It looks like Flower's working okay. So we can now go into the browser. So I've head over to the browser. I've typed in the localhost 5556. That was the port number we've identified in our Docker Compose file here. So we've set the Flower port here, 556, mapped over to 555 in the container. So yeah, it looks like Flower's ready to monitor our tasks that are completed. So here we've active, processed, and failed, and succeeded. So you can see that what's essentially is going to happen now is that we need to perform a task. The task is completed. That's sent back to our Redis container, of course, and then we can pick up from Flower here. We can pick up the results of that task. So at the minute, there's actually no way of us to actually run the task. So what we need to do now is think about this. So let's just go back into our example here. So we need to be able to now make a request to our server to perform a task, and then that task needs to then be pushed over to our Redis message broker in order for our Celery worker to pick up and to perform the task. Right, so we kind of need, if you like, an endpoint almost here. So let's go into our main file here. So what we're going to need to do here then is we're going to need to be able to post some data to our API so that we can then run our task. So let's go ahead and do exactly that. So we have app FastAPI implementation here. So we're going to use at app.post. So we're going to post some data. So we're going to set the endpoint here to example1. So that's where we're going to send the data. So let's go ahead and just create a new function here. Run task data equals body. So we're going to capture the data that we send in data. So amount equals, which is going to be an integer data amount. So here what we're doing is we're going to grab the data that we post across, and we're going to grab the amount, okay, from that data, the quantity, and that we've set, and then we're going to store that in amount, and then we're going to go for X and Y. So the amount here is just referring to the amount of delay that we want to create. That's going to be our A. If we go back into our worker, you can see here we're taking in 3 parameters here. A is going to be how long we delay the task to simulate how long a task might take. And then B and C here, we're just going to calculate. Right, so let's go back to main here. So X and Y is going to be our numbers that we're going to simply calculate. Right, so task equals create task. Inside of create task, so task equals, so create task dot delay amount X and Y. Okay, so that's our task. and then we're going to return JSON response. Right, so what's create task? So what we're going to need to do now is just bring in a few tools. So from Celery worker, so let's put it here. From Celery worker, we're going to need to import our create task. Yep. Okay, so that was the task name in our Celery worker. It's called create task. So we're going to import that in. Where's I mean? There we go. So that's it. So now we're just basically utilizing that delay amount X and Y. So we're going to pass those in. So those are obviously going to be captured. Go back to our worker. They're going to be captured as A, B, and C. We're going to define the sleep time, and then we're going to return B and C. So in addition, we are using body here. So we need to take that from FastAPI. We need to import that in. So let's import that in. You can see that we received an error here. It's not been defined. So you can see once that's been done, the app has now started up again. So now we have to fire a task off to our API. So here we can use curl. Now I'm using Windows here. So I do have Git bash as well available. So I can utilize this to run curl commands. So here I'm going to send a request, a post to localhost 8000. That's where our server is. And then we set out a new endpoint called /ex1. So content type application JSON. I want to send some data. And what I want to send here is I want to send the amount, which is the time delay, the data X, which is going to be 1, and Y is going to be 2. So when that gets processed by our task, if we go back into the worker here, you can see that A is going to be used for the time sleep. So that's going to create a delay, and then B and C is just going to record a count or create a calculation. So 1 + 2 is going to return 3. So we give that a go, and it says here internal server error. Okay, so this is good. So we have an error, which is always good to try and resolve. This one's really simple. It says here name error, name JSON response is not defined. So you can see here I've got a bash here, a git bash shell open here, where I'm running my curl commands. So I'll go back to the previous. If you're not familiar with the terminal, you can see that I've got an error response here, JSON response. So if I go into my main here, all this really means is that I've not actually imported from FastAPI JSON response. So here I'm trying to return a JSON response. And of course I can't do that. It looks like everything else is working. So my app is now started up again. So I'm just going to run this command again, press up. Just going to send the same data across again. And then this time you can see I get a response, task 3. So you can see that I could change it to calculation or result. That probably make more sense. So if I run it again, it should now say result is 3. Oh, I probably didn't save it in time. There we go, result is 3. All right, so I can change this up, obviously, so we can confirm this is working. So if I change this to 4, the result should be 5, right? So 4 + 1 is 5. So it looks like everything is working okay. Now, if I go back into Flower, you can see that I've processed 6 tasks and 6 were successful. So we can clearly see that Flower is picking up from our back end there, the tasks that are happening, and we can see this in real time. So for example, if I had to change the amount here to 10 seconds, so that's going to be essentially a 10-second wait. If I go into Flower here, you can see that we have an active task. It's being processed. Well, obviously we're simulating this. This task might take an X amount of time to complete. So once it is completed, you can see it goes over to succeeded, and the task has been completed. Okay, so that should give us a starting point to start working with Celery and FastAPI. Future tutorials, we can now go ahead and explore how to implement different tasks or set up different tasks with Celery. This should act as a good starting point just to get us over the line starting to use Celery with FastAPI. So I hope you enjoyed the tutorial. Thank you very much for listening, and I hope to see you in the next tutorial.